All right, getting into it today, first thing we're talking about is the incenter of a triangle, okay? The incenter of a triangle is going to be equidistant from all of the sides of a triangle. So if you're ever told, here's the incenter, you know it's the same distance from all three sides, and that can certainly be helpful for us. So if we have the incenter, the way it was created was by finding the angle bisectors, okay? This is the point where the angle bisectors overlap. So here it says use a compass and a straight edge to find the incenter of this triangle. Now to save us some time, I already have the triangle up here on the board, but if you don't remember how to find an angle bisector, you need to go back and watch Construction Lab 3, which shows us how to make an angle bisector, how to construct that using a compass and a straight edge. So you can go, should have the link down there in the description. You can click that, yeah? Okay, now notice what happened here. Here's our triangle. There are the three vertices plotted. But when we find the angle bisectors, it bisected each angle, so now each side, each piece of the angle split into two congruent pieces, and that happened 3 times, and these lines that are drawn through all intersect at the same point. Once you find 2 angle bisectors and you see where those are going to intersect, you know that's where the third one is going to intersect also. So there's the incenter where the 3 angle bisectors overlapped, where they intersected. Again, go back and watch Construction Lab 3 if you don't remember how to construct an angle bisector, because that's going to be difficult to do if you don't know how to do it. Moving on. Moving on here, we have the triangle angle bisector theorem. Now, if we bisect an angle and we draw that line through our triangle, then this splits our triangle proportionally. This says that this side of our triangle over here is going to be proportional to that piece of this side. Well, the ratio of those two is going to be proportional to the length of that side over there to the length of the smaller side down there. Notice PM over PO, PM over PO, to NM over NO. Okay? So here, if we know that AB is 15, we know that DC is 8, we know that AB is 20, we want to find BC, I'm going to let that be X. Well, we know that 15 to 8 is going to equal 20 to X. The entire side to that piece is going to equal the entire side to that piece, because that angle was bisected right there, so we're able to use the triangle angle bisector theorem. That's what we just did. That theorem allows us to set up these proportions. Now, we talked about the incenter. We also have the circumcenter. All right, the circumcenter is the point created when we draw all 3 perpendicular bisectors, okay? And again, if you don't remember how to draw a perpendicular bisector or to create it using our construction method, Construction Lab 3, same link in the description. Go watch that, refresh yourself if you don't remember how to draw a perpendicular bisector. So, the perpendicular bisector is going to be equidistant from every vertex, okay? That point is the same distance away from each vertex. Again, can be pretty helpful to us. So the incenter is the same distance away from each side. The circumcenter is the same distance away from each vertex. Notice here we have a circumcenter drawn. Okay, this is the same distance away from each vertex. It was created by the perpendicular bisectors of each side. Now, the circumcenter is actually also special because if we were to inscribe our polygon, inscribe our triangle in a circle, draw a circle to where each of the 3 points of our triangle is on the circle. If we were to do that, then the circumcenter would be not only the center of our triangle, it would also be the center of our circle. And that's because each of these distances to the vertex, from each vertex to the center, would not only be the same, well, they'd be the same length, so that would mean they'd be the radii of our circle. Okay. So a little bit more information than we exactly need to know right now, but we're going to build on that. Okay? So the circumcenter, same distance away from each vertex. And of course the circumcenter is created by the perpendicular bisectors. So take a look here. We want to draw what? The circumcenter. We have a point at 2, 2, that's A. We have a point at 8, 2, 6, 7, 8, 2 right there. That is B. That's A, there's B, and C is at 4, 7. Yep, and that's C. Okay, we want to find the circumcenter. Remember what the circumcenter is? It is the intersection of the perpendicular bisectors. Well, I can clearly see that the center of this right here, from 2 to 8, that's going to be right there. 1, 2, 3 units, 1, 2, 3 units. So if I'm going to bisect it with a perpendicular bisector, it would have to be at a right angle going through the midpoint. And so there is my perpendicular bisector to this side, splitting it into 2 congruent pieces. But I need at least one more. If I can draw at least one more, then I can see where they're all going to intersect, and I will have my circumcenter. So I need to perform a perpendicular bisection. Now, here's the problem. This board doesn't like me. It doesn't like these tools I have here. So just bear with me here. All right, so we can see roughly where this is on our coordinate plane, but we don't have the exact point. Okay, so we're going to find it. Here's how we're going to find it. I can see that midpoint right there. You calculate the midpoint between A and C, it would be that point 3. Four and a half. Okay? Well, we can calculate the equation of that line right there. Okay? The equation of that line is going to be the equation of the line that goes through this point but is perpendicular to that blue line right there. So, I'm going to let this line right here, think of this line as being line Y. All right, there's our great. All right, so we know it's going to be perpendicular to this blue line. Well, that blue line has a slope of up 1, 2, 3, 4, 5 over 2. So that means ours needs to be a negative 2/5. If that blue line has a slope of 5 over 2, ours needs to be the opposite reciprocal, but it needs to go through the point 3, 4 and a half. So I'm going to use my point slope form. Y minus 4 and a half equals M times x minus the x coordinate. Y minus 9 over 2, which is 4.5, equals a negative 2/5 x plus 6/5. I add 9 over 2 to both sides. And 6/5 plus 9 over 2, quick little that'd be 57/10. And we already know what the x coordinate of this is going to be. This is a vertical line going through 5. We just need to know what the y coordinate is going to be. And we're trying to find that point that is our circumcenter. The x coordinate is 5. We're trying to find the y coordinate. So I'm going to plug in a 5 to this equation to find out what y is going to be when the x value on this line is 5. And so this would give me y equals a negative 2. If I put in a 5 for x, I get a negative 2 plus 57/10. And negative 2 plus 57/10 get negative 20/10 plus 57/10. That gives me 37/10. So this would be 5 comma 37/10. All right, final problem should be a lot easier actually. We've got R, S, and T, our 3 gas stations, and these are, well, these form a right triangle for us. And what we want to realize here is that the circumcenter on a right triangle is going to be honestly a little bit easier to find, okay? Because we want to find the point that is equidistant from all 3 gas stations. All right, if it's equidistant from all 3 of the endpoints, we're talking about the circumcenter. Well, here we can see the midpoint. We could draw our perpendicular bisector pretty easily. From 2 to 8, we can see our midpoint's going to be right here and is going through. Now look at where that point is. That point is actually on the triangle. Pretty wild, but that means our circumcenter is actually on the hypotenuse, and that circumcenter would be the point 4, 5. That is the point where the storage facility would be in this situation.